Hello everyone and welcome back to another video. Today we're going to do 3 quick expansion examples. The very first one is expanding a good old-fashioned set of binomials which creates a quadratic equation. This is typically where we start most of our quadratic units. So we're kind of starting a series of quadratic videos here, hence why we are looking at example 1, a core concept from the quadratics work. So when we do quadratics, we have our two sets of brackets. Okay, I've got y is, well, that's the terrible y. Let me fix that. I've got y. Okay, that's a terrible y again. Let me just, it's the pen. It's the pen. Here we go. All right, I've got y is equal to 2x minus 3, and I've got x plus 7. Now, I've left the y part here. Oftentimes when these units start, we don't always include y equals. Sometimes you're just going to get a set of brackets that looks very similar to these brackets here. Now, why I'm including the y is because I feel like it's good just getting your eyes used to seeing that when we are talking about quadratics, where this whole topic leads to typically is looking at sketches, looking at graphs, how we can create a equation and a graph of a quadratic function specifically. So we're just kind of leaving it there, getting used to seeing it, so when we get to the sketching part, it doesn't look so weird that suddenly there's the letter y involved in our equation. So to expand my set of brackets, the process I like to use, there is a few acronyms that exist. Let me grab this and pull it down a little bit. There's a few acronyms that exists. The most common acronym that I see is FOIL. FOIL stands for, I'll write it here, FOIL stands for, in fact, let's do this a little bit better. We're going to use our different colors. FOIL stands for first, outside, inside, last. Now, the F for FOIL stands for first. That's multiplying my first terms in both brackets. That gives me an answer of, my first term is 2x multiplied by x. That gives 2x squared. Then I do my two outside terms. 2x multiplied by 7 is going to give positive 14 lots of x. I now do my two inside terms, and I've used blue again, but hopefully this is still clear to see. I do negative 3 multiplied by x. That gives minus 3x. And for my last two terms here, I have negative 3 times positive 7. I'll push this across a little bit. That is going to give negative 21. So that is the expansion of my two brackets. Now, like all things algebra, we want to simplify and we want to collect like terms. Hopefully we can notice that in the middle here, I've got 14x minus 3 lots of x. These are, in fact, like terms. I can collect those like terms. So I'm going to have as my result, I'll write my whole thing in blue. I've got 2x squared. 14x minus 3x gives plus 11x. Minus 21 is the fully expanded version of my brackets. Now, the training wheels approach is to use FOIL to the first two terms, the outside two terms, the inside two terms, and the last two terms. That would be, it might be a bit mirrored, so my finger's not going the wrong way, apologies, but that would be how I would recommend going about expanding our brackets. We get a little bit quicker at this, we can do a little bit more in our head, we can get to our answer a little bit faster, but if we're beginning, we're starting out with quadratics, this is how we expand brackets. I recommend the acronym FOIL. We're going to go away from FOIL later in the topic, but for beginners, for learning, for the very beginning, I think FOIL works fantastic. Let's go across to example number 2. Now, example number 2 looks almost the exact same. It is a binomial expansion. This time, though, we want to pay attention to my brackets. I have an x and a 5, and what do I know it? I have an x and a number 5. So my numbers are exactly the same in this situation. Now, the only difference is that I've got a negative here, or a minus sign, and I've got a positive term here, or a plus sign. I'll zoom in a little bit so we can see that nice and clear. So this has got a name. We typically refer to this as the difference of two squares or dots. There is a second name, the difference of perfect squares or dots. So they're the two main names you'll see. They're the two main names your teachers will most likely use as well. Now, I will talk about why this matters. However, we can do the exact same thing we did just before. I can say, okay, I have y is equal to, I've got my set of brackets, I've got x minus 5, I've got x plus 5, and I can expand using my FOIL acronym. Now, without writing my FOIL out, I'm going to do my first two terms, that is x multiplied by x. I'll use a highlighter instead, actually. We've got x multiplied by x. X multiplied by x is going to give x squared. Then I do my outside two terms. For my outside two terms, that is going to be this x term here again, multiplied by this number 5. So x multiplied by positive 5 is going to give plus 5 lots of x. I now do my inside two terms. If I do my inside two terms, I have this 5 multiplied by this x, and I should include the negative, right? That's negative 5 multiplied by x. Minus 5 times x gives minus 5x. And I now do my last two terms, and I'm going to use red because I'm slightly running out of good highlighter colors. And I'm going to do -5 multiplied by +5, and I get the answer of -25. That's if I expand using FOIL, and I get the same terms. And I can do this for all my difference of two squares problems. The reason why difference of two squares is important for you to recognize is more going to come in a later video when we talk about factorizing. However, if you can understand it here, it makes the factorizing lesson significantly easier. So what we hopefully may have noticed, I'm going to use red because red's the perfect color for this, is if I look at my numbers in the middle here, my +5x and my -5x, well, 5x minus 5x actually equals 0. So my terms in the middle cancel out, and what I wind up with is the first term, x squared, minus the second term, 25. So I get x squared minus 25 is my final answer, because my numbers in the middle cancel out. This is so critical to so many harder problems, understanding where the terms in the middle disappear to. Now, why it's called difference of two squares, and why I prefer the name dots over dops, is pretty simple. Okay, if I just consider the brackets I had before, okay, I'm going to rewrite the brackets here. I've got x minus 5, I've got x plus 5. All I've done is I've taken my first term, I have squared that, and I've taken the difference. Difference in maths means I've subtracted the second term squared. So we have a really fast way of getting to our answer where I look at my question, I go, okay, that's x minus 5, x plus 5, that is going to be x squared minus my second term, which in this case is 5, and I can square that. So basically the process for any difference of two squares question is square the first term minus square the last term, done. To show that, with not an example I've written out, but just to show a fast version of that, if I had something like, let's do x minus 3, x plus 3, I could immediately go to my answer. If I'm just expanding my brackets, I should include my y equals part here as well, sorry. If I'm just expanding my brackets, I could simply go to my first term, x, I can square that, minus my second term, which is 3, I can square that, 3 squared gives 9, and I'm finished. Okay, the third and final example is expanding a perfect square. So again, we can FOIL all of these questions. If we know the first one, that applies to the next two, but there are some ways to do this one a little bit quicker. I'm going to rewrite my question first, and I don't know why I'm choosing green, but I'm just going to choose green anyway. I get 3x minus 4 all squared. The first thing to recognize is I cannot just square the first term, square the last term. It's a little bit similar to what we did with dots. We can't do that on dots. We can't do that. What we have to do instead is recognize that x minus, sorry, I shouldn't say x, 3x minus 4 squared is the same as 3x minus 4 multiplied by 3x minus 4. The same way if I told you 3 squared, that's equal to 3 multiplied by 3. Same idea. I can expand out my square. Now, once I realize I'm expanding, we see we're going to get like a full 3 terms when we simplify down, like a full quadratic equation. Now, I can do FOIL. And I'm going to show FOIL because I feel like it's just a good way to realize, hey, FOIL works for everything, and also it helps us figure out the faster paths to our answer. So if I do FOIL, and I'm not going to put all the highlighting in colors. We've seen it twice. I multiply the first term. 3x multiplied by 3x is going to give, well, 3 times 3 is 9. X times x gives x squared. I now multiply my 3, I can't help but do color, apologies, multiply my 3x by my -4. 3x multiplied by -4 gives, well, 3 times -4 gives -12, and my x is going to stay. I now do -4 times 3x, and that's also going to give -12x. I do -4 times -4, that gives +16. Now, I'll move my face a little bit. And we notice the middle terms this time. Some people just look at this and think it cancels. Well, -12x, it is not going to cancel out. So I'm going to collect my like terms. I get 9x squared. -12 gives -24x. And I've got +16. But there was a little bit of a pattern occurring here. There's a pattern for all of these. I am squaring my first term. And I'm squaring my last term. I'm going to show that in green. I've got 3x here. Well, 3x squared becomes 9x squared. Oh, sorry, 3x all squared becomes 9x squared. And I've got my -4 on the end here. Well, -4 squared gives +16. The middle term, though, is a little bit harder to see. Okay? The rule we normally use for expanding perfect squares quickly, or the rule I like to use, is the rule normally referred to as 1, 2, 1. Now, the 1, 2, 1 rule is kind of simple. I square the first term. I want to multiply my two terms together. If we look at negative 24x, well, 3 times negative 4 gives negative 12. That is where this number here comes from. If I double negative 12, I get negative 24. So the pattern we have is it's the first term squared. I multiply my two terms in my brackets and double it. And then I square the last term. 1, 2, 1. So I'll show that again quickly with a different example. We'll just do something with pretty nice numbers that we can get a feel for what we're doing. If I do something like, if I'm just expanding the brackets of, I'll do 2x, let's just make it positive, 2x plus, 1's a bit of a rubbish number, plus 5. That's a terrible 5. Plus 5 squared. What I can do is, I square the first term. Well, 2x squared gives 4x. Sorry, 2x all squared gives 4x squared. I feel like I'm saying that a bit wrong. That gives 4x squared. I now multiply the two numbers together. So I'm going to be multiplying my 2x multiplied by my 5. Well, 2x multiplied by 5, I'll write this in small that we can see, is going to give 10x. And I'm going to double that term. If I double that term, well, 10x times 2 is going to give me positive 20x. And I now square the last. 5 squared gives positive 25. That is my answer. That is the fast way to expand any perfect square. With that being said, we don't always need to be Lightning McQueen. We can just write out my brackets next to each other, do FOIL, collect like terms. It's not that much slower. It's more helpful when we're factorizing to start seeing these patterns, okay? So the main takeaway from this video, if we can do FOIL, we can do all of it. There's a few tricks with difference of two squares, and there's a few tricks with perfect squares that will make our work a little bit quicker and can help later on in the quadratic unit when we are trying to factorize. I hope you guys enjoyed the video. Any comments, feel free to leave them down below and I'll get back to them as soon as I can, and I'll see you guys in the next one. Bye everyone.